Hello everyone, my name is Arya Devdar and this is part 5 of NCERT Class 10 Science, Chapter 9, Light, Reflection and Refraction. Okay, so in the last part we started with refraction of light, right? So we saw what is refraction, we saw the laws, and we also ended with the refractive index of light. Okay, so in this part we are going to see spherical lenses. So what exactly are spherical lenses and how many types are there, right? So spherical lenses. Then we are going to see the terms related to spherical lenses, right? So terms related to lenses. Then we are going to see the rules for drawing ray diagrams. Rules for ray diagrams of lenses, lens image formation, right? So some rules. There are total 3. So we'll see them. After that, we are going to see the main topic, which is image formation. Image formation by concave and convex lens. First convex and then concave lenses and their uses. So this is what we are going to cover in this part. So let's get started. Okay. So the first topic is spherical lenses. So what exactly are spherical lenses? Okay. So you might have once, seen a magnifying glass, right? Or you might have used a magnifying glass sometime in your life. So magnifying glass, if you see it carefully, the surface of the lens which is there, it is curved, it is not straight, it is not a piece of glass, it is curved, right? It is not a like a regular piece of glass. It has been curved such that the middle part is thicker than the ends, right? So that is a lens basically, and that is a spherical lens. So what is the scientific definition of spherical lens? Well, a bound transparent material bound, obviously it has to be transparent to pass light, right? So bound by two surfaces of which one or both surfaces of which one or both surfaces are spherical are spherical forms a spherical lens. Okay, so that is known as a spherical lens. Okay, so what does this mean? Basically, a piece of glass which has at least one spherical surface is a lens. It is a spherical lens. Okay, so in such lenses like which I have written here, if one surface is spherical, so they would be of this type, like this. So this is plane and this is spherical, or they also may be of this type. Okay, right? So this is curved inwards. This is curved inwards, and this is a plane surface. Okay, so but we are not going to study these type of lenses in our chapter or in 10th standard. We may see them in higher classes. For now, we have the lenses which are covered by spherical sides on both the sides. Spherical lenses on both the sides. Okay, so there are two types. You might see the drawing here. Okay, so I made it in advance. So there are two types. The first one is convex lens. The second one is concave lens. Same name as mirror, just it is lens. That's all. So what is a convex lens? A lens which is bulging outwards. So the surfaces, they are bulging outwards, right? So that is known as a convex lens. Okay, a lens which has two spherical surfaces. It is known as it can also be called as a double convex lens, but it is usually just known as a convex lens. Okay, because both the sides are convex, right? So double. Okay, so this is how you draw a lens. This is the convex lens. Okay, and a concave lens. Concave is inwards. Both are inwards. Okay, bulging inwards, they are known as concave. They are also called double concave lens, but they are also simply called concave lens. Okay? Now, I'll just give you a quick relation which will help you understand the further part. Right? So, we have already studied mirrors, right? There are two types of mirrors, concave mirror and convex mirror. So, it might be a little hard for you to digest, but understand this. A convex lens is similar to concave mirror, and a concave lens, it is similar to a convex mirror. Okay, उल्टा है. Concave convex, convex concave, ऐसा है. It's not the same. Okay, so if you understand this, if you remember this, then the further part will be very easy for you. Okay, similar to a concave mirror. What do I mean? The first thing which I mean is that we know that a concave mirror is a converging mirror, right? It directs the parallel rays towards the focus or to a single point. This exact same thing happens in a convex lens. Hence, a convex lens is also converging lens. And a concave lens, it is same as convex mirror. And we know that a convex mirror is diverging. It diverges the light rays, right? They appear to come from the focus, but they do not actually meet at the focus, do they? So it is a diverging mirror, and hence the concave lens, it is also a diverging lens. So in this way, both of these are similar. Okay, convex, concave, concave, convex. Understood? Okay, moving on. Now we'll see some terms related to spherical lenses, which will be important for you when you draw the ray diagrams, right? So let's see one by one. First of all, there are two focuses. Okay, or let's start with center of curvatures. So there are two center of curvatures. Why? Because here two circles or two spheres intersect to form one lens. See, I'll show you how. This is one sphere, for example, and this is another sphere. Okay, so both of these spheres, they have their own centers, right? Both of them have their own centers. So those centers, they are known as the center of curvatures for the lens. Those centers, they are known as the center of curvature for the lens. So here, say this is the center of curvature, and here, this is the center of curvature. In mirror, we used to denote center of curvature by C. Here, we are going to denote it in the diagram by 2F. 2F. Okay, so here this will be 2F, this will be 2F. But both 2 points cannot be named the same thing. So we'll write it 2F1 and 2F2. Simple. Okay, moving on. Now we have, as there are two center of curvature, there will be two foci. So there are two foci. This is 1, this is 2. So F1, F2. Understood? Okay. The center of the lens, the center which is present on the lens, the point, it is known as the optical center. Optical center, it is denoted by O. And an imaginary straight line passing through the two centers of curvature, it is known as principal axis. So this is the principal axis. Understood? Okay. Now, the effective diameter of the circular outline of a spherical lens, it is called the aperture. So what is the aperture? I'll show you. So this basically, it is the aperture. This is the aperture or the diameter of a lens. So in this chapter, we will study about lenses whose aperture is much smaller than the radius of curvature. Aperture should be very small compared to the radius of curvature. So very thin lens basically. Very, very thin lens. Okay. In this chapter. Again, the same nomenclature, nothing much, not much difference. Distance between optical center and center of curvature is radius of curvature. So, and distance between optical center and focus is focal length, F. Okay, easy. Okay. Now focus. The definition for focus for convex lens. Convex lens is a converging lens. Okay. So when several rays of light parallel to the principal axis, they fall on a concave lens. These rays, after refraction, they converge at a point on the principal axis. And that point, it is known as the focus of converging lens or of convex lens. Okay. And for concave lens, when several rays of light parallel to the principal axis, they fall on a concave lens. These rays, after refraction, they appear to diverge from a point on the principal axis. Appear to diverge. And that point, it is known as focus, principal focus. Okay, understood? So terms. These are all the terms related to spherical lenses. Now we'll move on to rules for ray diagrams. Now there are some rules regarding the ray diagrams. What are they? See, one by one. I have drawn the diagrams in advance to save us time, right? So moving on to the first rule. If a ray, it's the same as for mirrors, okay? So if the ray, it passes parallel to the principal axis, it will refract through the focus on the other side, obviously. Okay, so it will refract through the focus. Understood? Oh, I'm sorry. I'm so sorry. I've drawn this wrong here. I'm so sorry. I've drawn this wrong. Yeah. Here, actually, what will happen, I'll show you. For concave lens, it will not actually pass to the focus because it is a diverging lens, right? What will happen? The focus is here. So it will appear to come from the focus. It will get diverged, but it will appear to come from the focus. This is what happens in a concave lens. Sorry, I drew it wrong before. Yeah, anyways, understood? So parallel to the principal axis, passes through the focus or appears to come from the focus. Number two, rule number 2. If a ray, it passes through the focus, then it emerges parallel to the principal axis. If it passes through the focus, emerges parallel to the principal axis. Through the focus, parallel to the principal axis. There is no difference for concave and convex in this one. Okay. Moving on to the third and last rule. It is also simple. A ray passing through the optical center, it will go undeviated. There will be no deviation. It will not bend at all. It will go straight. Understood? This is again same for convex and concave. So these are the 3 rules which you have to keep in mind when drawing the ray diagrams. Okay, now let us move on to image formation by convex lens. Now, as I said, convex lens is the same as concave mirror, or it is similar to concave mirror. So in concave mirror, we used to have 6 cases. Similarly, in convex lens, we also have 6 cases. Okay, so case 1, object is at infinity. So we know that from infinity, parallel rays, they arrive. So there are 2 parallel rays I have drawn. Parallel to the principal axis, they will converge at the focus. Converge at the focus. Hence, position of the position of the image, it is at focus. Position of the image is at focus. Okay, the size of the image is highly diminished or point sized. Highly diminished or point size, whichever. And the nature, it is real and inverted. Real and inverted. So you see, it is the same as concave mirror currently, right? Okay. Pretty similar. I mean, not same, because here the image is forming on the other side of the lens, right? Obviously, it's transparent. Okay, moving on. Anyways, the second case, which is object beyond 2f1 or object beyond center of curvature. Again, 2 light rays have been directed. One is parallel and the second, so it passes parallel, so it emerges through the focus. The second one goes through the optical center and it goes undeviated. They meet at a point. Okay, so and where the image is formed, The image position is between f2 and 2f2, right? The size is diminished. You can see it has been reduced a bit, not much though. Diminished, only diminished. And the nature, it is inverted, right? So real and inverted. Okay, understood? Object beyond 2f1. Third case, again we are moving the object closer. Object at 2f1. Again, two rays have been directed, one parallel to the principal axis, it passes through the focus. Another one passing through the optical center goes undeviated. They meet at a point and the image is formed exactly at 2f2. So the position of the image is at 2f2. Okay. The size of the image is exactly the same. Exactly same size. And the nature, it is still real and inverted. Nature is real and inverted. Okay. Now, moving on to the fourth case. The object is between 2f1 and f1. So object is between center of curvature and focus. Again, two rays have been directed. One parallel goes through the focus, one through the optical center undeviated. They meet at a point. The point lies beyond 2f2. Hence, the position of the image is beyond 2f2. Beyond 2f2. The size is enlarged or magnified. Right? Not much, but it has been enlarged. And the nature is still real and inverted. Okay, moving on to the fifth case. Here, the object is at f1. Object is kept at f1. So here, two rays are again directed. One passing parallel, so it goes through the focus, and one passing through the optical center, and it is goes undeviated, right? Now these two rays, which the refracted rays, they are parallel to each other. So that means the image will form at infinity. If you remember, it was the same for concave mirror, right? When the object was kept at focus, the two rays, they were reflected back and both were parallel to each other. So the position of the image there also was at infinity. Here also the position of the image will be at infinity. Okay, at infinity. The size of the image will be highly enlarged. Highly enlarged, right? Highly magnified, very big size. And the nature will be real and inverted. Very, very similar to concave mirror. I hope you can relate, right? And you might have guessed the last case in concave mirror was also that you got a virtual and erect object image. Here also you will get a virtual and erect image even in a lens. Okay, so this is kind of, magical. Even though it is transparent, the image is still formed behind the lens on the same side of the object. So see how it happens. The object is kept between f1 and o. A ray is passed parallel, it goes through the focus, and a ray is passed through the optical center, goes without deviation. Now as you can see, the two refracted rays, they will never meet in real life, but when they are traced back, they do intersect at a point. So the image is formed at the point, and hence the position of the image is on the same side of the lens as the object. On the same side of the lens as the object. The size is enlarged, as you can see, it's on the same side. And the nature, it is virtual and erect. So it is similar to the last case of concave mirror, right? So these are the 6 cases for convex lens. Now let's move on to the uses of convex lens. So what are convex lens used for? So convex lens are basically used in magnifying lenses. Okay, they're used in magnifying lenses. They are also used to magnify the images of tiny objects, right? And one more use of convex lens is that they are used to correct hypermetropia. Correct hypermetropia. Oh, I'm sorry. Hypermetropia or farsightedness. Okay. So this you will learn in your next chapter, human eye, but for now just remember the name. So the uses are actually not given in your NCERT, but I thought like I have told them in mirrors, right? So I should tell about lenses as well. So these are the main two uses of convex lenses. Now let us move on to concave lens. Okay. So image formation by concave lens. Now as I said, concave lens is similar to your convex mirror, right? So in convex mirror there were only two cases. So similarly in concave lens there are two cases. So the first case, object at infinity. Okay. So the object is at infinity here. This is the object. Two parallel rays parallel to the principal axis are thrown at the lens and they appear to diverge from a point on the principal axis, which is the focus, right? So that means the position of the image is at f1 or at focus. The size of the image is highly diminished, and the nature, it is virtual and erect. So basically, like in convex mirror, and like in mirrors, the convex mirror always formed virtual and erect images, and the concave mirror always formed or mostly form real and inverted. Only in one case, virtual and erect, right? Similarly, in lenses, convex lens always or mostly forms real and inverted. Only in the last case it formed virtual and erect. And in concave lenses, they always form virtual and erect images. Okay, understood? Now, we'll move on to the second case, which is object between infinity and O, optical center, right? So it can be anywhere. It can be here as well. It can be here. It can be here or here, wherever, right? So I have taken it between to f1 and f1, but that really doesn't matter. It should be between infinity and optical center. That's all. So again, two rays are passed. One is parallel, so it appears to diverge from the focus. The second one passes through the optical center without any deviation. So these two, the refracted rays, they will never meet in real life because they are being diverged, right? But when they are traced back, they do meet at a point which is between the focus f1 and O, optical center, right? So the position of the image is between, so it is between f1 and O. The size of the image, it is diminished. It is smaller, right? And the nature, again, virtual and erect. Okay, understood? So these are the two cases for concave lens. Easy to understand because you have already studied mirrors, right? So now we'll just look at the uses of concave lens. Very simple. So the uses of concave lens, first use is that concave lenses, they are used for to make the peepholes or the door viewers, right? So it is used to make the peepholes or door viewers, right? So basically, as the concave lens, it diverges the light ray, so it gives a wider field of view, right? So you can see through before opening the door, you can see who is there outside, right? That is why it is used for peepholes. They are known as peepholes, or people also call them door viewers. Okay, door viewers, kind of odd, but okay. And the second use, it is used for correcting myopia, which most people have actually. Myopia is nearsightedness, so you have glasses for seeing distant objects. Okay, so correcting myopia. Again, you will learn about this in your second chapter of physics, which is human eye and the colorful world, right? So these are the two important uses of concave lens. Other than this, the lenses are generally used in telescopes, binoculars, and all that. But both the lenses are combined, so I didn't write all of that down. So anyways, we have covered all the topics for this part. We have seen mainly the image formation for both convex and concave lenses. Okay, so that's it for this part. Thank you so much.